All right, I want to continue by talking about a couple of other types of games that we should know about. First is called a coordination game. Um, so a coordination game is often a game with multiple equilibria and a game in which the players have to coordinate their actions. And the easiest sort of game to think about for a coordination game would be one where imagine that automobiles have just been invented and there are two drivers out on the road and each of them has to make a decision. Am I going to drive on the left side of the road or the right side of the road? If each drives on the left side of the road, imagine these are utility payoffs. Each one gets a utility of 10. If driver one drives on the left and driver two on the right, imagine that they then collide, and that gives them negative utility. If one chooses right and two chooses left, again, they get negative utility. And if they both drive on the right side of the road, then they get positive payoffs. Okay. It's clear that these are the two outcomes that are preferred. Let's see if they're equilibrium outcomes. If driver two chooses left, then driver one would prefer left. If driver two chooses right, then driver one would prefer right. If driver one chooses left, driver two prefers left. And if driver one chooses right, then driver two prefers right. And so this is a game with two Nash equilibria. Which one prevails is the issue. And it requires that the two players coordinate their actions. Okay, and it doesn't really matter which outcome we get, which is why we see some countries where drivers always stay to the left and some countries where drivers are always on the right. But we don't see countries where we have left and right as the rule. Sometimes we see that as a bad habit that occurs, but that's never the rule or the law. And the law is meant to create this coordination between players. So that's a coordination game. A second thing we should talk about is another way to solve games. We've talked about backward induction. There's another strategy for solving games, which turns out to be useful when games get more complicated. And it's called elimination, of dominated strategies. Is what this procedure is called. And so to make this useful, let's choose a more complicated game. And so suppose we have a game, suppose we have a duopoly where there are two firms, each of whom produces some level of output. And the game is about choosing the optimal level of output for each firm. Okay, and suppose so these are firms that compete using quantity. So let's call this firm 1 and firm 2. And let's just suppose that each of them could produce either a low, a middle, or a high level of output. And each of them has to decide what is best for them. Okay. In terms of profitability, we could make a payoff matrix that looks like this: 73, 25, 57, 42, 66, 32. And so these are payoffs for each firm in each possible combination of outcomes. Call this 80, 26, 35, 12, 32, 54, 28, 27, 63, 31, 54, 29. Okay, so when you look at this game, when you look at this payoff matrix, it's messy, isn't it? And you don't look at this and have much intuition about where it's going to come out. And so what we will do is to use a strategy that takes into account all possible outcomes and does it in an orderly way. And so what we'll do is we'll start with firm one, and we'll say, suppose firm one chooses a low level of output, what's the outcome? Then we'll say, suppose it chooses a middle level of output, what's the outcome? And finally, if it chooses a high level of output, what's the outcome? And once we've done that, we will have taken all possibilities into account. So let's do this. Firm one chooses a low level of output. That means we're in this top row. Firm two now has potential payoffs of 25, 42, or 32. They're going to prefer that. And so firm two is going to choose middle. If firm two chooses middle, then firm one has payoffs of 57, 35, or 63. They're going to prefer 63. So firm one is going to produce or choose the high level of output. And what we've learned from this is that when firm one chooses a low level of output, the process of going through the game means that firm one is going to want to move away from that. Firm one's not going to want to stick with the low level of output. They're going to want to go to a high level of output. When they switch to high, firm two has a payoff of 27, 31, or 29. They're going to prefer 31. And so this, in fact, is an equilibrium outcome. Okay. And so what this tells us is that firm one, low, is a dominated strategy, meaning that if we start with that strategy, we will see that it is eventually dominated by a different strategy, and this is never going to be an equilibrium strategy, so we can eliminate that. Now let's work through the other possibilities. If firm two chooses a middle level of output, so we're here, firm one has payoffs of 26, 12, or 54. They're going to choose high level of output, so they get that higher payoff of 54. When they choose 54, firm two looks at, or firm one rather, has payoffs of 54, 32, or 66. Firm one is going to prefer the low level of output, which gives them the high payoff of 66. But we already know that when firm one chooses the high level of output, firm two chooses middle. And when they choose middle, firm one now goes to the high level of output. And we end up in the same place. So firm one choosing a middle level of output is a dominated strategy as well. If we start out with firm one choosing middle level of output, they will want to move away from that and end up here. Finally, if firm two chooses the high level of output, firm one has payoffs of 27, 31, or 29. Firm, that should be firm one and firm one. If firm one chooses the high level of output, firm two will choose middle, and that then is the Nash equilibrium for this game. Okay. You need to go through all the possibilities because it's possible you could have more than one Nash equilibrium. And until you've evaluated either all of the rows or all of the columns, either way is fine. Until you've gone through each of those possibilities, you can't be sure that you've identified all the Nash equilibria in the game. All right, I'm going to stop there and we'll come back and we'll do one more example for you.